welcome to clip 1 of 6.1 summary notes. This is actually happening before your exploration. A polygon. Polygon is something you say when your pet parrot flies away. Polygon. Anyhow, polygon is actually a closed two-dimensional figure formed by line segments. A closed two-dimensional figure formed by line segments. What a polygon is not is open or curved. So I usually say, pretend you have a dog named Fido, and Fido wants to be in a polygon for his pen. This crazy shape that I've drawn, formed by all segments, is a polygon. Fido's very happy because he has a big area to run around in. So there's Fido. Fido's very, very happy because he has lots of room. If you did this, it's not made with straight sides, and Fido's angry because it's curved. Not allowed to have curves. It has to be made by line segments. If you do this, we have a problem because poor Fido's going to escape and run away, so you can't have an open figure. And one other thing, this is actually two different polygons, not a polygon, because Fido would be very, very angry with you that you left poor Fido in one little area and he can't get to the other area that's fenced off. Names of polygons that you should know from elementary: we have the triangle, the quadrilateral. Now that one looks like a parallelogram, but it is a quadrilateral. That's the basic name. A pentagon, a hexagon, a heptagon has 7 sides, an octagon, which is what a stop sign is made from, and then we have the nonagon, which is 9 sides, the decagon, which is 10 sides, and I skipped the 11-sided, it's just an 11gon. This that has 12 sides is a for 2, decagon. So 2 plus 10 being 12. You need to be familiar with these names so that you can write them or know what they are when they have problems. So we know how many sides and vertices. This one has 12 sides and 12 vertices. Another couple basic definition stuff: regular polygon versus irregular polygon. And no, it's not that they've had their fiber versus not had their fiber. A regular polygon has all sides and all angles congruent. It has to have both. If it doesn't have all sides and all angles, it is not a regular polygon. Above, most of the pictures are regular polygons above, except for the quadrilateral. A regular quadrilateral would have all sides and all angles congruent, and you may have guessed it would be a square. Irregular polygons would be like the parallelogram, or like the isosceles triangle. Yes, it has 2 angles and 2 sides that are congruent, but not all angles and all sides. So irregular is just not regular. To be regular, it has to have all sides and all angles congruent. That's the definition of a regular polygon. Convex versus concave. Convex is where all the vertices are pointing outward. And I'm not doing this very well. So, and it should have been straight. So anyhow, they are all pointing outward. For example, on this pentagon, all my vertices are pointing outward. In addition, if I were to connect all of the diagonals, which is going to take me a while, they would all fit inside. All diagonals fit inside, and it is going to be pointing outward. If you were to trace the 2 rays, they would come to a point pointing away from the shape. Concave is where I have a shape maybe like this, where some of them point outward, but at least one of them points inward. If you look, this is pointing inward to the shape. In addition, when I connect my diagonals, which is any vertex to vertex that's not a side, there's one diagonal falling outside. I think it's easier to remember whether it's pointing out. If all vertices are pointing out, it's convex. If any are pointing in, it's concave. With the conclusion of this quick video of basic vocabulary, you are ready to start your exploration. There is an exploration helpful hint guide that is posted for you to reference as needed. You should be working with at least 2 people. For clip 2, we will be looking at the Polygon interior angle sum theorem.